fine. We are approximately reaching the end of the course, and today we'll talk about probability. It's an interesting chapter, easy one, small hints to understand probabilities. Show you before I start solving the questions. Okay, so probability, guys. Okay, check this with me. Any system in the world, it's equal to 1. Like if we have a pizza, okay, we can say, if I just cut it into 6 pieces, what's the probability to have 1 piece? It's 1/6. What's the probability to have 3 pieces? 3/6, which is equal to 1/2. So all the systems, okay, it's start with a 0, okay, probability, which is impossible, and the highest one, which is what? 1. So the number or the numbers that representing the probability of something, it's between 0 and 1. Or in another way, if we're talking about percentages, okay, it's between 0 and 100%. And always remember, the probability has 2 ways: theoretical probability and experimental probability. Okay, experimental, it depends on experiments and the events. Okay, so I'm going to start solving questions as usual. 5 questions that help you. You can start the chapter or after you end the chapter. Okay, so question 1. Let's check now. Question 1. Here we go. So a die is rolled once. Okay, the sample space of the die is sample space means all the possible outcomes that comes from the dice. What are they? It's 1, 2, 3, 4, 5, 6. Of course, those are the possible answers if you are looking for the die, okay, that gives you, okay, but it's not the probability. So what's the probability to have 1? 1/6. What's the probability to have 3? Don't tell me 3/6. It's what? It's again 1/6. What's the probability to have 2 and 3? Is going to be what? 2/6, which means 1/3. Okay, so remember always when you're talking about probability, okay, it's like a ratio or a fraction representing the outcome over the sample space. And by the way, I need from you to note this down. Okay, in the probability chapter, the word, okay, or and. Or means plus, addition, and is multiplication. Remember, or is addition and is multiplication. So let's check now. What's the probability to have a 3 in the die? Die is okay. There are 6 outcomes. I want to have 1/6. That's when we want to have the 3. So here the answer is what? 1/6. And what's the probability to have an even number in the die? Even number means 2, 4, 6. There are 3. 3 out of 6, which means half. So 3 out of 6, that's equal to half. So this is the end of question 1. This is very easy one you can start the chapter with. And always remember, the probability of a number in a die, 1/6. The probability of a tail or a face, okay, in a coin, 1/2. The probability of the spinners always depend on the case. If it's a prime number, even number, sum of prime, sum of even numbers, sum of normal numbers, depends on the spinners. Okay, always check these 3. Okay, so in the American program we are not going to talk about the card decks. Okay, it's just only dice and coins, also spinners. Okay, check with me question 2. Question 2, let's check here. Okay, on a test, 5 true-false questions, okay, are asked. If a person, okay, taking the test knows nothing about the material and guesses randomly, okay, at the answers, so what is the probability that the person will answer all the 5 questions correctly? So remember something here. There are 5 questions true-false. True-false means 50-50%, which is 1/2, 1/2. So if I want to write to, let's say, the probability of making all of them correct, so the first question that's going to be 1/2, okay? And the second question is 1/2. The third question is 1/2. The fourth question is 1/2. The fifth question is 1/2. But mister, why you are putting multiplication? Check this. 5 question true means the first one true and the second one true and the third one true, and the fourth one true, and the fifth one true, and means multiply, 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 multiply. It's like intersection of event. We are doing the events together. Please don't tell me you are going for checking true, false. That's not going to help in the M1 exam. We need the fastest way, okay, to score the M1, okay? So check this. It's 1 over 2 times 1 over 2 times 1 over 2. Okay, 5 times, and the answer is what? C. Here we go, question 3. Let's say about independent events. Independent events, like if I say, what's the probability that Mr. Wright is teaching the probability lesson in the same time one of you eating a burger? So, come on, what's this? It is like independent events. We want to calculate the intersection of these events in the whole world. So you are eating a burger in the same time I'm doing my class. It's intersection. You multiply both probabilities to get the answer. So let's check an example for that. Okay, check this. The probability that there will be, okay, a lightning storm tomorrow is 1 over 8. That's the probability, okay. And the probability, the probability that there will be a lightning storm the day of 11. So I have 2 events. So what's the probability, okay, that there will be, okay, a storm tomorrow and the day after tomorrow? So it's easy. Since the intersection, I'm doing the 2 events, so it's 1 over 11 times 1 over 8, which the answer is what in this case? 1 over 88. And this is the question. Check this. So it's 1 over 8 times 1 over 11, 1 over 88. Okay. See you in the next question. Okay. Now, before I start question 4, just put in your mind, there's a complement event. What's a complement event? Let's say the probability that I'm going to eat a sandwich is 3 over 4, which is 0.75. It's the complement of that. Complement means the other way around, like I will not eat the sandwich. So 3 over 4 eating the sandwich, so 1 over 4 not eating the sandwich. So 0.75 eating the sandwich means 0.25 I'm not going to eat the sandwich. Why specifically these 2 numbers? We said at the beginning of the video, all the systems in the probability equal 1 or 100%. So in this case, the complement event, which means the other way around, if you want to find that complement event, let's say if I am eating the sandwich 3 over 4, the complement of that 1 minus 3 over 4, which is equal 1 over 4. I think you understand my point here, okay? So this is a complement event. Let's go for an example and check. Okay, see. In this, okay, the probability that there will be a lightning storm, okay, tomorrow is 1 over 8. And the probability independently, okay, there will be a lightning storm after tomorrow is 1 over 11. My question is differently now. What is the probability that tomorrow there will be a lightning storm and the after tomorrow will not be a lightning storm? Tomorrow a lightning storm that I know, Mr. it's what, 1 over 8. But after tomorrow not be a lightning storm, of course is not going to be 1 over 11, which is the complement of that event. Not means the complement. And if you want to calculate the complement, which means 1 minus 1 over 11. Okay, 1 minus 1 over 11. So in this case, 1 minus 1 over 11 is equal 10 over 11. So the intersection of lightning storm and the after tomorrow, there will be no lightning storm. So in this case, 1 over 8 multiply 10 over 11. So in this case, what will be the answer? Of course, that's going to be 5 over 44. So check, it's 10 over 11. Okay, see you in the last question. Last question for today, question 5. See, now there will be a dependent event. Dependent event, okay, which is like depending on the event in the same time. Let's say if I'm doing an experiment, okay, and the experiment is related, all the events are related, like you say a sequence or a series of experiments, okay, they are related to each other. As an example, let's say there will be a jar which is full of marbles, red, blue, green, whatever, as you like, okay, and I'm calculating, okay, let's say there will be 3 red, 5 green, 6 yellow, red, green, yellow, 3, 5, 6. If I want to take the red, it's 3 out of the total, okay, 5, 6, 11, 3, 14. So 3 over 14, that's the red. Okay, if I took 1, are the marbles going to be the same count, which is 14? Of course not. So that's ongoing depending event. The next event depending on the first event, which means I need to put in my mind that the second event will not be the same one, including all marbles, because one is being taken out. In this case, look at the word which will come in M1 and might, okay, change the value of the question, I mean the meaning of the question, which is without replacing. Without replacing means I will take that marble out and I will not return it back. So the count will be different. Check this question, and this is the end of the probability chapter. It will help you to understand this chapter. So a jar contains 3 red, 5 green, 2 blue, and 6 yellow marbles. Okay, a marble is chosen at random from the jar. A second marble is chosen without replacing. I chose one, and the second one without replacing is what? Okay, the first one. So what is the probability of choosing a green and yellow? If I want to choose green, green is going to be 5. 5 over the total, how much? 5 over, sorry, the total is, okay, we have 3, 5, 2, so okay, 10, 16. So 5 over 16, that's the count, yes. 2, 3, 5, 5, 10, and that's 16. So this is the probability of having what? Green, which is 5 over 16. And this means multiply what? Yellow marbles. Okay, how many yellows do I have here? So let's check. Blue. Okay, 6 yellow. Okay, mister, no problem. It's 6. But my question is that going to be the same number, which is 16? No. What will be? It's going to be 15. Why? Because without replacing it, I cannot return that. I cannot calculate, include the red one that I took at the beginning. Okay, yes, it's the green one that I took from the beginning. I cannot return it back. So my count will be in the denominator instead of marbles. Now what I'm having, 15 marbles. Okay, and at the end, this is my solution. Check this. 5 over 16 times 6 over 15, which is equal 1 over 8. And that's the end of the questions. Please read this chapter very well. If you have any questions, be my guest. Send me a message or an email or on WhatsApp. I'm available 24/7. See you later.